Okay, part 3 of naming compounds. We're asking ourselves that same question that we're starting with each time. Is there a metal? Well, this time we are saying no, so we don't have to ask our second question. These are called type 3 binary compounds, and we use prefixes to signify how many of each of the element is present. And these are all for you to memorize. 1 is mono, 2 is di, 3 is tri, 4 is tetra. That's one that people often get incorrect, so that's a good one to study extra hard. 5 is penta, 6 is hexa. That one comes in handy a lot when we deal with organic molecules. 7 is hepta, 8 is octa, 9 is nano, 10 is deca. Again, you will need to memorize those. Okay, we're going to end each of our things with IDE like we did before. We're only ending the second element with IDE, even though we're probably dealing with only nonmetals here. So if I have this one, I have 3 carbons, which means tricarbon, and then 8 hydrogens, octahydride. Tricarbon octahydride. Again, note that the IDE is only on the second of our elements, not on the first one. We sometimes get into an instance where we want to use mono to indicate that we have just one of our first element, but we're never going to use mono on the first one just to save ourselves some time. So if I have SiO2, I have 1 silicon, and I'm just going to say silicon, and then I have 2 oxygens, so dioxide, silicon dioxide. H2O, if I'm using this notation that we've been using and not just calling it water, it is dihydrogen monoxide. So I use my mono on the second one, but never on the first. Dihydrogen monoxide. I can write symbols from the names as well. The prefix goes directly behind the element symbol this time. We're not crisscrossing like we did with metals. So if I have carbon tetrachloride, it means I'd have just 1 carbon because there's no prefix in front of the carbon. Chloride is Cl, it's from chlorine, and tetra is 4, so I have CCl4. Disulfur dichloride means that I have 2 sulfurs and 2 Cls. Chloride, chlorine, Cl. Notice that we do not reduce to the lowest common denominator for these covalent compounds like we did for the ionic ones. Before we would have said, oh, this is just SCl. Well, that doesn't give us the whole idea here. And the reason that we do not ever go to that lowest common denominator for covalent is because there are so many different ways for these elements to combine that SCl2 may be a completely different molecule, different properties than we have with S2Cl2.